Hello class, this is Dr. Senpai here. We're going to be doing a chapter 8 problem. So let's get into it. So the question is, the following diagram, which is right here, shows a circle of a center O and radius R. The shaded sector OACB has an area of 27 centimeters squared. Angle AOB equals theta, which equals 1.5 radians. So the answers we're trying to find here is to find the radius and calculate the length of the minor arc ACB. So let's get started, shall we? To find the radius, we're going to use the equation area equals 1/2 theta r squared. So we're using this formula because we already know the area, which is 27 centimeters squared, and theta, which is 1.5 radians. So like I said, the area is 27 centimeters squared equals 1/2 theta, which is 1.5 radians. And we're looking for r squared, or r. So what I do now is I multiply this side by 2 to get rid of the 1/2. So multiply by 2, multiply by 2. So what you get is 54. That cancels the 1/2 equals 1.5 r squared. Now you divide by 1.5 to get rid of the 1.5 on this side. 1.5. Now you get 36 equals square root. 36 equals r squared. Sorry, I'm getting ahead of myself. Now, to get rid of the r squared, you have to square root both sides. Square root, because you're looking for r. Now you get square root of 36 is 6 equals r. And there you go. That is A. Alright guys, moving on to chapter 9, law of cosines, law of sines. We're going to work on this law of cosines problem. So here's the formula for law of cosines. C squared equals A squared plus B squared minus 2AB cosine C. And we're given this triangle right here. We have to find the length of BC, which is this side right here. So our C squared would be BC, which is unknown, equals A squared, which is 13. Your A and B really don't matter. It's your C squared is really the one that's matter, because that's the opposite from the angle. So A squared is 11 squared plus 13 squared minus 2 A times B, 11 times 13, cosine of the angle, which is 42 degrees. So then you square root all of that to get the value that's not squared. Then you get BC equals 8.80. There you go. Pretty simple. Now on to law of sines. Now we're doing law of sines. So remember, you can only do a law of sines if you have two sides and a non-included angle, or two angles and a side that are known. So in this case right here, we have two angles and a side that is known. So we're looking for side AC. We plug in our handy dandy formula, B over sine B equals A over sine A. So B right here is just the angle, what is the side we're looking for, is opposite to the side angle of 58. So that's what goes on bottom. So B sine 58, because it's the opposite angle, equals A, in this case which is 12 centimeters, equals A over sine 39. It's 39 because this is the angle opposite to the side. So then you get to this step, and what you do here is you multiply both sides by sine 58, then you get B equals 12 sine 58 over 12 sine 39. Plug this in your calculator, you get B approximately equals 16.17 centimeters. There you go. Now we're moving on to chapter 10, and this is the general sine function for sine graphs. So it is y equals a sine b x minus c plus d, where b is greater than 0. So a affects the amplitude, b affects the period, and c affects horizontal translation, and then d affects vertical translation. So to find the principal axis, it's just d, y equals d. To get the period of a sine function, you do 2 pi over b, so 2 pi over whatever number this would be. We're going to do examples later, don't worry. And amplitude is just the absolute value of A. Alright, now we're going to consider the stuff we just talked about over here into this function right here. Consider function 2 sine 3 x minus pi over 4 plus 1. So the amplitude is this right here, absolute value. So amplitude would be 2. Amplitude. Because if we remember from over here, A affects amplitude. And then to get the period is B So you get b, you 2 pi over b equals period, right? So this would equal 2 pi over 3. That would be your period. Now, this affects horizontal translation, so this is shifted pi over 4 units to the right. Since it's a negative, it's to the right. And this affects vertical translation, and this is 1 unit up. And here you go, understanding a basic sine graph, sine function. Okay, now we're on the cosine function, and as you can see, it's very similar to the sine function. There's not much difference. A still affects amplitude, B still affects period. To get the period, it's still 2 pi over B. Same thing, it still affects horizontal translation, whatever's inside these parentheses. Then D still affects vertical translation. All you have to remember for cosine graphs are whenever you start, it always starts at 0, 1. Unlike sine, where it starts at 0, 0. So there you go. Alright, now we're on the tangent functions for graphs. So this is still pretty similar to sine, cosine. It's just to get the period now, you only do pi over b instead of 2 pi over b. And the amplitude is always going to be undefined. And then there you go. Now we're on to double angle formulas. So, given that sine theta equals 3 over 5 and cosine theta equals negative 4 over 5, find sine 2 theta and find cosine 2 theta. So, to find sine 2 theta equals 2 sine theta times cosine theta. So, we know that we have 2 right here, and sine theta equals 3 over 5, and cosine theta equals negative 4 over 5. Right? So you multiply these two together, you get negative 12 over 25. Multiply this by 2. Equals negative 24 over 25. Cool. Now, second one. Cosine squared theta. So cosine theta is negative 4 over 5. You have to square that. Minus sine squared theta. Sine theta is 3 over 5. Square that. So you square these out and subtract them, you get 7 over 25. There you go, double angle formula.